Ionization enthalpy. What do you understand from ionization enthalpy? Ionization enthalpy is the energy required to remove an electron from the outermost orbit of the atom. And atom should be a gaseous atom and in the isolated state. Alright. So, the energy required to remove an electron from a gaseous atom in isolated state is known as ionization enthalpy. Just look at this figure. If an electron is present in the outermost orbit and it is attracted by nucleus, you can imagine it is in the attraction of the nucleus. If you want to remove this electron out of the orbit, what do you have to give? You have to give energy, and this energy is known as ionization energy. You, in short, you write it as EI, or how you write it as delta I and H. So ionization enthalpy could be written either ways, either IE ionization enthalpy or delta H also you can write. Few more facts about ionization enthalpy. What are those? What do you think? When electron will be easily removed in a smaller atom or a bigger atom? In a bigger atom, electron will be far away from the nucleus, attraction will be less, electron will be removed easily. If it is near to the nucleus, attraction will be more, then energy required to remove this electron will be more. Alright. So, smaller the atom, more will be ionization enthalpy, right? And bigger the atom, distance between nucleus and electron will be more, and the energy required to remove this electron will be less because it is already in less attraction. You got that point? Smaller the atom, bigger will be ionization enthalpy value. Bigger the atom, smaller will be ionization enthalpy. Alright. Next point comes, what do you think? Screening effect and atomic size, what the relation do they have? The relation is, more the screening effect, more will be size. More size, ionization enthalpy will be less, right? Keep it in mind. Bigger the size, less will be attraction of the electron, less attraction, so less will be ionization enthalpy required to remove electron. Alright. Few more points are mentioned over here. What are those? Ionization enthalpy also depends on stability of the configuration. And what is that? What is that? Let's see. Stability of configuration, if we talk about stability of configuration, is fully filled subshell. Fully filled subshell is more stable. Fully filled, then half filled. After fully filled, the other one is half filled. So to remove this, let me check out. Okay. Fully filled is most stable. Then comes the half filled, and least stable is partially filled subshell. Partially filled. And what is that? Fully filled and half filled and partially filled. Okay. So fully filled is S2 or P6 or D10. This is fully filled subshells. Half filled is S1, P3 and D5. These are half filled subshells, and anything other than these two will be called as partially filled subshells. So most stable is fully filled subshell, then half filled, then partially filled. More stable means more attraction. Remember this, more stable means more attraction. More attraction, more will be the energy required to remove the electron. Alright. So in the case of fully filled subshell, more energy will be required, more ionization enthalpy. Then half filled, slightly lesser than that. So ionization enthalpy will be in the order of, in fully filled subshell, ionization enthalpy will be highest, then half filled, and the least will be in partially filled. Alright. I hope you got that clearly. Next, few more points are mentioned over here. Let's suppose you removed one electron from an atom, then it becomes from M, it becomes M plus. The size is smaller, right? So another electron, if you remove, first electron removed, the energy required to remove first electron is known as ionization enthalpy 1, IE 1. If you remove second electron from the same atom, then the ionization energy will be known as IE2. And if you remove third electron from the same atom, energy will be known as ionization energy 3. All right. You can say either ionization energy or ionization enthalpy both mean the same thing, right? So what is the relation between IE1, IE2, IE3, IE4? Because the size of atoms keeps on decreasing as you remove electron. First electron is removed, m to m plus. If second electron is removed, m plus becomes m2 plus. Third electron is removed, m plus 2 becomes m plus 3. Size is decreasing, attraction of the outermost electron is increasing, so ionization enthalpy is also increasing. I hope you got those points. So you can say simply successive ionization energy values keep on increasing. IE1 is lesser than IE2, IE2 is lesser than IE3, IE4 is greater than IE3. So sequentially ionization energy values increase as you keep on removing the electron from the same atom, because size keeps on shrinking. All right. I hope we have cleared everything on this topic. Hopefully you understood everything.